Greetings, fellow nerds. In this video, we're going to make a triboluminescent or smash glow crystals. Crystals that flash light when smashed. First, we start with 100 milliliters of dry ethanol. The ethanol I'm using was dried by azeotropic distillation with benzene. Now we add 2.93 grams of dibenzoylmethane, 1.4 grams of europium nitrate pentahydrate that we made in a previous video, and finally, we add 1.9 milliliters of triethylamine. After adding a stir bar, we gently heat and stir the mixture until everything dissolves. Once everything is dissolved, take it off heating and carefully stopper the solution to prevent evaporation. As it cools, the product will crystallize out. Now we want large crystals, so we need to cool it slowly. The trick in this case is to place the flask into a thermos to keep the heat in. It will cool very slowly, allowing us to form the larger crystals we want. I'm going to leave that overnight to crystallize. There is our nicely formed crystalline product. Now we have to separate and dry it using standard vacuum filtration on a fitted funnel. First, break up the clumps, filter it by vacuum. Let me get rid of the waste. Now I'm washing the crystals with portions of ethanol to thoroughly clean the waste products from them. Give it an hour to dry. Now transfer it to a vial. Here we are. As you can see, we have a nice product of triboluminescent Europium Tetrakis Dibenzoylmethide Triethylammonium, also known as smash glow crystals. The first property of note is that because of the europium, it exhibits a very strong reddish-orange fluorescence. The camera doesn't render it properly, but the color is actually quite brilliant. But now for its most famous property, triboluminescence, or the generation of light when it's crushed or smashed. Here I've placed some in a bag, and I'm going to hit it multiple times with a hammer. And there you go, smash glow crystals. Now certain explosives and combustible materials also light up when smashed, but triboluminescent substances do so without burning. I can show this to you under the microscope. Here are the crystals close up. Let me turn off the backlight. Now the crystals are between two sheets of glass, and I'm going to grind the glass into the crystal to smash them. As you can see, the crystals aren't burning, they're just lighting up. You can also see that once the crystals are completely destroyed, they no longer work. This is because the triboluminescent process is based on destruction of the crystal structure. Once it's no longer crystalline, it can't glow. But unlike combustible materials, smash glow crystals can easily be restored by simply dissolving them back in hot ethanol and recrystallized. You can keep using them and recrystallizing them indefinitely. Now I'm just simply grinding the crystals against the glass wall of the vial. There are other good videos of triboluminescence on YouTube, including one by the journal Nature where they use tape to make X-rays. But as far as I know, this is the first video in the world of Europium Tetrakis Dibenzoylmethide Triethylammonium. The exact mechanism by which triboluminescent works is still under investigation, but the best theories so far propose that the breaking of the structure causes charge separation that releases energy upon recombination. This energy is picked up by nearby atoms, in this case europium, and released as light according to their ionization and fluorescence spectra. Other colors can be made with different compounds, but I only had enough money to make this particular stuff. Can you think of cool uses for this? Personally, I'd like a tennis ball or a soccer ball coated with this stuff. That'd be sweet. Thanks for watching. Please subscribe, rate, and comment your ideas for uses down below.